All right, let's take a look at a couple of problems here involving how to fill in a two-way table given some probability information. There's a chance you're going to be given different probabilities, and you're going to have to go through and fill in these tables. So taking a look here, it says 1,000 students at a local high school were asked which subject they prefer. The students are in the two-way table below. Complete the two-way table using the given information. The probability that a student is male is 0.56. This means that the number of males, divided by the number in the total has to equal 0.56. So I'm going to kind of use the right side of the screen here as I'll do most of my work here, especially for some of these early ones. So the number of males, I don't know. I'll call it X. Divided by the total number of students. And if I look at my table, I can look at the bottom row. Bottom row is totals. And the total number of students is 1,000. So X divided by 1,000 has to equal 0.56. I only know from Algebra 1 to solve this, multiply both sides by 1,000. And if I take 0.56 times 1,000, I get 560 males. 560. That's the number of males in total. So 560 goes in here for the total number of males. All right, let me erase that. Now, the probability that someone takes English. All right, probability that someone takes English. This is going to be the number of students that take English divided by the number of people in total. All right, again, number of people that take English, I don't know. I'll call that X. Divided by the total number of people, that's still 1,000. This equals 0.20. Multiply both sides by 1,000, and I find X to be 200. So 200 is the number of people that take English. So I'm coming down here to the total. With the column of English, total English is 200. So that one is found. All right, the next one says the probability that they are female and in science. So this one's a little bit different. This one is both female and science. So female and science. So if I want to find the number that are female and in science, and I divide by the number in the total, this thing has to equal 0.12. So the number in female in science, I don't know. I'll call it X. Notice I'll jump to the left side. Divided by the total number of people is 1,000. This has to equal 0.12. Maybe. 0.12. I don't know why that's not showing up. 0.12. There we go. No, I have them down at the bottom. Okay, so multiply both sides by 1,000. That means I get 120. 120. Now, 120 is the number that are in female. So row is female, and science is the column. So over here, row is female, and science is the column. I stop right there. Right there's my 120. So that takes care of the third one. All right, now let's take a look at the fourth one. It says math given female. this word is the big one. All right, when I am given information, I no longer care about the total. All right, that 1,000 is no longer a thing for me. This says I know that the student is female. So that means I am going to divide by the number of female. And of those females, the number that are female and in math. So of those females, which one of those females are also in math? And this has to equal 0.5. All right, well, in order to solve this one, I need to know how many females there are. And right now, my table does not tell me how many females I have. But I can get that pretty easy. And if I know that there are a total of 1,000, right here, total of 1,000 students, and 560 of them are male, then I can do 1,000 minus 560, and I can say that there are 440 females. Similarly, if I look at the column row, all right, there are 1,000 total. There are 200 that like English. There are 400 that like science. So I can add 200 and 400, that's 600. And I need it to be 1,000, so 1,000 minus 600 is 400 is left over for how many students like math. So a couple of these pretty easy to calculate just by plugging those things in. All right, so this is going to help me now. Now I can go back and do my original problem I was looking at. So I need the number of female and science. I don't know that. That's my X. The number of female students is 440. And this has to equal 0.5. So now when I want to multiply both sides to solve X, multiply both sides by 440. 440 times 0.5 is 220. So what is 220? Well, it's right here. Right? Female, I want to come over here. Row is female, and it is math. So I come over here. So female and math is 220. And now I have everything that I need. Because to fill in the rest of this table, now I can just look at rows or columns and make sure that they're all adding up properly. So let's take a look at the math column. I don't know how many males there are. I know there are 220 females, and I need a total of 400. So here I'll do 400 is my total, minus 220 of them are female, and I find out that there are 180 males. That way my column adds up to 400. Same thing again, anytime I'm only missing one square, I'm in good shape. I'll look straight down. I don't know how many males picked science, but I know 120 females did. The total has to be 400. So I can take 400, I can subtract 120 from that, and that gives me 280 as my total. So 280 plus 120 will give me my 400. All right, if I try this with English, I'm kind of stuck, right? Because I don't know how many males or females. I know it has to add up to 200, but it doesn't mean that it's 100 apiece. So what I'm going to do is I'm actually going to look at the row going sideways. I know I need 560 total. I know that 280 preferred science, so I can take those away. I know that 180 preferred math, so I can take those away. And I told you it didn't have to be 100 and 100, but if you take 560 and you subtract 280 and 180, you actually do get 100. So a coincidence does not always have to happen that way. And then to find the last one, again, I could do the same thing. I could actually pick column English, which I think is easier in this case, and do 200 minus 100. But just to show you how this one will work, I can take 440, the total of this row, subtract the science portion of this row, which is 120, subtract 220 as well, because that's the math portion. 400 minus 120 minus 220 is 100. So 100 can go in there as well. And that is how you fill in a two-way table. The nice thing about this two-way table, once it is filled in, it's really easy to find probabilities. If I wanted to know the probability that someone is male and preferred English, I just take the row male, the column of English, which is 100, and divide it by 1,000, the total. If I want to know the probability that someone is just male, I can take the total males, 560, and divide by 1,000. If I want to know the probability that someone liked science, I can take the total from science, which is 400, and divide by 1,000. If I want to know the probability that they were female and preferred math, then I can take 220 and divide by 1,000. I can do a lot of my conditional probabilities. If I want to know the probability, given that they are male, what's the probability that they like English? Then I just look at the male row of 560 and say, okay, 100 out of 560, so 100 divided by 560. Given that someone likes math, so look at the 400 students that like math, what's the probability that they are male? 180 divided by 400. So you can do all of your probabilities right out of this table. So let's take a look at one more example. This example says a total of 200 people attend a party, as shown in the table below. A person is selected at random to win a prize. The probability of selecting a female is 0.6. The probability of selecting a child, given that the person is female, is 0.25. And the probability of selecting a male, given the person is a child, is 0.4. Complete the two-way table below. All right, so what I'm going to do is I'm just going to kind of steal right here from the problem. What's it say? It says probability of selecting a female. So I'm going to use this sentence right here in red. And I'm going to use M for male, F for female, A for adult, and C for child. So this says that the probability of selecting a female is 0.6. This means that the number of females in total divided by the number of the total has to equal 0.6. So the number of females I know is 120. The total number is 200. I know that. And that equals 0.6. Yes, that is true. That's not going to help me solve for anything. But it does give me a probability. I can verify my table if I needed to. One of the things they could have done, really, they could have left out this whole column right here. And you could have filled it in with that information, I guess. But that information does not help me solve anything in the table. No harm, no foul. The next one. Probability of selecting a child given that the person is female. Okay, so now I don't care about the total number of people. I only care what do I know. I know about females. So I want to take the number of females. And of those females, how many of them, they're female and a child. This has to equal 0.25. So female and child, that would be row and column. So I don't know this square right here. That's what I'm looking for. Okay, so that's what I'm looking for. I'll call it X. The number of females, if I look at the row for females, that total is 120. And this has to equal 0.25. So in order to solve for X, I'm going to take 0.25 and multiply by 120. And 120 times 0.25 is 30. So 30 is row for female, column is children. I can plug a 30 in right there. And actually, this is enough to finish the table. This is enough to finish the table. Because I can now finish this row. I know this row has to add up to 50. The total has to be 50. If 30 of them are female, 50 minus 30 is 20. Now this row has to add up to 80. If 20 were children, that means 60 were adult. When I look at this row, it has to add up to 120. 30 of them were children. So that means 90 of them were adults. The only thing I could have done, I could have looked at the adult row and said 150 of them total, 60 were male, still has to be 90 female. Now, I did not use this last piece of information, but I am going to just show it just so you can see it. It says the probability of selecting a male given that the person is a child. All right, so I am given, what do I know? I know that I only care about, it's a child. So the number of children. In my numerator, I want to find what is the probability that that child is also male. And it says that that probability is 0.4. So I'm looking for child and male, which is, just so you know, I'll start it right here. That's child and male. That would be the number I'm trying to find. We found it easy, but let me show you how I could have found it using the conditional probability. So I don't know what goes in there. The number of children in total was given to us to be 50, and this has to equal 0.4. If you want to multiply both sides by 50, 0.4 times 50 is 20. So I would have gotten this 20 right here. I could have gotten by using the conditional probability as well. But once I get one of them in there, this one actually worked out real well that I was able to just get them all. So, I believe this is the last example. It is. This is a real good way of how to fill in those two-way tables, given some information about probability, and get that table filled in. Once that table's filled in, it gives you the option to start finding a lot of other probabilities. So I hope you got something useful out of this video, and thanks for checking in.